Here is how I make an answer key for my classes. Only imagine it's on a page. So the first thing we're looking at is find the exact radian measure that corresponds to the degree measure of 30. So I could look at this and say, well, most students probably recognize that 30 degrees is pi 6th radians. If they weren't sure, then they would take 30 degrees and multiply it by pi over 180 degrees. All right, and then you'd be left with a pi up here because, let's see, 30 goes into 186 times. So then we'd end up with our pi 6. The next one also, most students probably know that pi thirds is 60 degrees. But if they weren't sure, they would just take pi thirds and multiply it by 180 over pi. So that would get our pi's to cancel out, and 3 goes into 180 60 times. So that's where the 60 degrees is coming from, and on this one we have pi 6th. Last but not least, for these three, we are looking at find the exact value of the sine of 135 degrees. So I like to draw a reference triangle for that. I know that 135 degrees is somewhere over here in quadrant 2. That was a squiggly line, but here is my angle, right? So 135 degrees. So that means I have a reference angle of 45 degrees right here. So we can go ahead and complete our triangle. And let's see, that's a 45, 45, 90. So I know it has 1, 1, root 2. But we have to be careful here. We would have to be careful here because this goes left 1. So that's technically a negative 1. But that's okay because the sine of an angle is the opposite over the hypotenuse. So the opposite is 1, the hypotenuse is 2. So that would be 1 over root 2, which when we rationalize that, that becomes root 2 over 2. So if this got typed into a calculator, you'd get back 0.707. So unless the student knew that this was root 2 over 2 was 0.707, the easier way to get it maybe is to have a reference triangle. All right, let's move to the next. All right, for the next one we're looking at here, it says use the hypotenuse, which is this piece over here in the figure, and express the lengths A and B shown. So here's A and here's B in the figure in terms of theta. So I guess I would look at the sine first. I'll say that the sine of theta is going to be equal to the opposite, which is A, over the hypotenuse, which is shown to be 24. So when we solve that for A, we're just going to multiply both sides by 24. So we'd say that A equals the sine of 24, or 24 times the sine of theta. To get the cosine, let's see. This is my adjacent side, so that deals with the cosine. So the cosine of theta is going to be the adjacent over the hypotenuse, right? So adjacent over hypotenuse. So this is the adjacent to this angle, and this is the hypotenuse. So the same as over here, we're just going to multiply both sides by 24 and solve this for B. So B is going to be 24 times the cosine of theta. All right. So there is number 4. I'm halfway there. So the number 5. So here it reads that the sine of theta is 5/13 and the tangent of theta is negative 5/12. We want to find the secant of theta. So I know that the sine is positive in both quadrant 1 and quadrant 2. And the tangent is negative in quadrant 2 and quadrant 4. So what they have in common is quadrant 2. So that's going to be a quadrant 2 angle. So let me draw quadrant 2 here. And I'll draw myself a little triangle. So 13 and 5. Because I see 5 over 13. So opposite over adjacent. So the angle, technically, this is the angle. theta, and this is the reference angle. So I know from like a long time ago that this is going to be 12. So let me put a 12 in there. And it's not only going to be 12, it's a negative 12 because that's to the left of the origin, right, going this way. Plus, we know that the tangent is 5 over negative 12, so opposite over adjacent. So what we want to do is find the secant. So let me jot this down. The secant, well, I know that the cosine and the secant are reciprocals. So adjacent over hypotenuse is what we would use for the cosine. So we're going to use the hypotenuse over the adjacent for the sine. So the hypotenuse happens to be 13, and the adjacent side is negative 12. So we would probably simplify that by saying negative 13 twelfths. So that takes care of number 5. All right. So here is the 6th one. And the 6th one says we're going to find how high this rocket is. It says the rocket is fired straight up. It's tracked by an observer over here on the ground a mile away. So this is 1 mile. So at the instant, theta is 30 degrees. So when this is 30 degrees, how many feet off the ground is the rocket? And they're giving us that this a mile is 5,280 feet. So, and then we're going to round our final answer to 1 decimal place. So let's go ahead and set this up. If I'm dealing with opposite and adjacent, I'm going to be looking at a tangent. So the tangent of theta is going to be the opposite, which is h over here. And I'm going to divide it by 5,280 feet. So multiply both sides by 5,280, and we get an equation that looks like this. Okay, but we're told at the instant this is 30 degrees. So we're going to look this up and say, all right, tangent of 30 degrees. So I could just multiply this out in a calculator and come up with a 1 decimal approximation. So that's what I'll do. So when I do this, I end up with 3,048.4 feet. So this height would be 3,048.4. So that takes care of number 6. All right, so find the angle labeled theta, that's this angle here, and round your answer to 1 decimal. So when you know 3 sides of a triangle, that's telling you that you're going to be using the law of cosines. So you can go ahead and just label this any way you'd want to. I suppose I could call this A, B, C. So that would make this side A, this side B, and this side equal to C. So I'm solving for B. So that means I want this formula. B squared equals A squared plus C squared minus 2AC cosine of B. So I'm going to solve this for the cosine of B. So that means I will bring over my A squared and my C squared, and then I'll divide by negative 2AC, and that equals the cosine of B. So at this point, you're just going to make your substitutions. So you'll be looking at B is 9, so 9 squared minus A squared minus C squared all over 2 times A times C. Oops, and let's not forget that's a negative. So the cosine of B equals all this mess right here. But we type that into our calculator, that's no problem. That would give us what? The cosine of B equals, it's a long decimal. Typing it into my calculator, I got 0.19791. It looks like repeating 6. So if I take the inverse cosine of both sides of this, I would find out that B equals, see, that's positive, so that tells me it is going to be an acute angle. So my B is going to be 78.6, my calculator tells me. So that is solving for the angle marked theta. Right, so 8th and final problem. So we are going to refer to the figure at the right over here, And we're going to round all my final answers to 1 decimal, which would be normal. Find the angle opposite the longest side. So this happens to be my longest side right here. So I will label it. It doesn't really matter how we label these things. I'll just start with A here, B here, and C here. So this angle, theta, that I'm looking for is going to be angle C. So if this side is A, or if that angle is A, this side is A. If this angle is C, this side is C. And if this angle up here is B, then this side is B. So let's do this. I'm going to be, let's see, I'm solving for big C. So I'm going to start with C squared equals A squared plus B squared minus 2AB cosine of C. So if you want to solve for cosine of C first, go ahead. We bring our A squared and B squared over, and then we divide both sides by negative 2AB, and that would be equal to our cosine of C. So that gives us cosine of C. All right, type this into your calculator if you want to. C squared would be 6 squared minus A squared is 4 squared minus B squared, which is 3 squared, divided by negative 2 times A times B. And when I type this all into my calculator, I'm going to have to move to the right here. I find out that the cosine of C is about negative. Okay, so negative 4583. So in that last one, this answer I got was positive. So that told me that the other angle was going to be it told me it was going to be acute. This being negative tells me that this is going to be obtuse. So when I take the inverse cosine of C, I end up with 117.3 degrees. And then we had one more piece here to this one. It says find the area of this triangle. So it's not a right triangle, so in order to get the area here, the easiest thing to do is use Heron's formula, right? This guy here. I don't even know why I'm writing this down. I wouldn't actually write this on my answer key, but Heron's formula. I have to find out what's called the semi-perimeter by adding up all 3 sides and dividing by 2. So that would be 3 plus 4 plus 6. Had a glance at that again real quick. All over 2. So that's 13 halves or 6.5. So this is Heron's formula right here. Heron's formula says you take the square root of this product, the semi-perimeter times S minus A times S minus B times S minus C. So, and I guess I did not need to make my radical that long, but we'll go back and substitute. So when I substitute this, I get S 6.5 times 6.5 minus, it doesn't really matter which order you put these in because you're multiplying them all together. 6.5 minus 6. Okay, now I do need to make it longer. So I'm just typing this whole thing into my calculator. You don't have to simplify on the way or whatever. But when I do that, I'm going to come up with about 5.3. And there's no units, so I guess I'll just write units squared. So that is the area of that triangle to the nearest tenth. So 5.3 units. So there you have it. If you got value out of this, please share it with one of your classmates so they will get some value too. And in the meantime, remember to keep up with your homework because math is not a spectator sport. The only way to learn math is to do math. So until next time, this is Mr. Noldy signing out.